This task asks us to write a procedure. This is a procedure because ultimately this is designed to simply show the price. You could imagine such a system being used maybe if a customer wanted to get a quote before they were going ahead with doing any sort of a sale. This would be quite easy to convert into a function as well, because instead of printing the outcome, we would return the outcome and then make it part of a bigger system. But for now, we're keeping it more straightforward and we're writing a procedure. So let's define the procedure then. So let's call it getPrice. And we are going to require an input this time. I'm going to call that input flowers so that we know how many have been provided. So the task, if you read the task, it says at the end that input should be checked by the procedure to ensure that it's positive. So let's just make sure that if flowers is, let's say, less than or equal to 0, that would mean that the number of flowers being bought is either 0 or it's less than that. So we could print some sort of a message here just to say no flowers have been bought, or there's maybe like an invalid input or whatever, and we could just say return at this point, which will eject us out of the procedure completely. We could separate this, of course. We could say that if flowers is equal to 0, then that, and if flowers is less than 0, then we could print an error message to say this is not a valid quantity of flowers, like that, and then we can use the return keyword to eject and get out of the function. These brackets are actually surplus to requirements, and I'll just take them out. Okay, so we have dealt with the two cases where we sort of validation to do. Okay, so we'll just stick in the word validation here, just to say that that's what's going on in that block there. So as long as both of those validation strategies come back with false results, that gives us confidence that the number of flowers that has been passed in is a positive number. It would be beyond the scope of the task to check to see whether the value that was input was a real number, or if the value that was input was actually an alphabetic or punctuation character. So we're not going to go down that route. We'll just stick to what the task did ask us to do. Okay, so the florist is selling these flowers for £3 per flower, £3 per stem. But if they buy 6, then that counts as a bunch and it's going to cost 16. So what we should try to do at this point is break up the value of flowers into two numbers. One of them is the number of bunches that were sold. So if you want to know how many bunches were sold, then take the number of flowers, divide it by 6, and look at the whole number part, and that will tell you how many bunches there were. In order to divide by 6 and keep only the whole number part, we use the div operator like this. Okay, so this is the use of the div operator. It gives you the quotient only. Okay, so if we then want to know how many loose flowers that leaves left over, then you can take the number of flowers and you can divide by 6 and observe only the remainder. So if we do that, that's called use of the mod operator, and it's the remainder only. So that will separate out then the bunch of flowers, or the large basket of flowers that the customer arrives to the counter with, and it will separate them out and say for instance they had 31 flowers, then that could form 5 bunches of 6. So if you take 31 and you divide it by 6 and only look at the quotient, 31 divided by 6 is 5 1/6. Therefore we only look at the number 5. But how many loose flowers does that leave? Well, if you divide by 6 and you only look at the remainder, there is 1 loose flower. Okay, so in order to calculate the cost, the overall cost of this is going to be the number of bunches multiplied by £16 each, plus the number of loose flowers multiplied by £3 each. So this means that any bunches will be sold at a slightly cheaper overall price. And finally, to complete the task, we now have to display this cost. we are dealing with whole numbers, therefore we know that this will always end in 0.00. So we could omit the 0.00, or we could include it to make it look more like a currency value, but let's just bomb on ahead with the job of displaying the result. Okay, so the total cost is going to be, we're going to put in a pound sign, and then we're going to join on the value of cost. It is going to be a whole number, so we don't strictly speaking need to put in 0.00, but let's just put in 0.00. One subtle little thing here is that the data type of cost is actually an int, therefore we're going to have to typecast this into a string in the Python language, because the plus operator is being used here for string concatenation, and it doesn't like, and I missed that double quote, it doesn't like having integers and strings, or basically it doesn't like concatenating strings with non-strings, so it doesn't matter what the data type is. Okay, so next what we should do is test that we have no bugs or significant problems here. We're going to create a main body for our program, and we are going to call our procedure. So earlier I had done sort of a mental check in my head to make sure that it worked with the number 31. So if we say get price 31, then because we are calling a procedure, it is perfectly okay for that to stand on its own as a line of code, because it's going to cause an action to take place, and ultimately it's going to cause this print statement to appear on the screen. Something else that we should test while we're here is we should test it with a 0 value, because that will output a specific output, and similarly we should try a negative value as well. Okay, so let's run this. We should see 3 different output statements. Okay, first of all, £83 sounds convincing, and then no flowers have been bought is whenever you put in a 0, and this is not a valid quantity of flowers is when you put in a negative number. So generally I'm happy with that. Let's just be a bit more careful about the number 83. So when I did the number 31, I said that it would be 5 times 16. So 5 times 16, 5 tens are 50, 5 sixes are 30, so that's 80. And then one loose additional flower will bring it up to 3, bringing it up to 83. So I'm generally happy with that. You can test it with other values, of course, if you wish. You could test it with the number 6 just to make sure that it copes okay with the number 0 when there are no loose flowers. Let's just run that, I'm sure it'll be fine. Yep, that's it. So that forms one bunch, and one single bunch is £16. And I'm happy to sign that off then as a working version of a solution to the problem.